3, it's very similar to question 2 in the case that you're given a system of equation and you want to use your calculator to graph and find the point of intersections. But because we're using our TI-84 calculator, we need these two equations to be in y equal to form. So to start, I'm just going to, again, label these equations. So my first equation, I'm labeling it as equation 1. And my second equation, I'm going to call equation 2. Now I want to isolate for y for equation 1 and 2. I'm going to start by isolating for y for equation 1. In this case, I have 6 minus y equals to negative 4, x minus 2. Now the first thing I want to do is I want to multiply negative 4 into my bracket. So I'm going to multiply negative 4 into x, and I'm going to multiply negative 4 into negative 2. And if I do that, my left-hand side remains the same, and my right-hand side, what I should be getting is negative 4x. And this part is interesting. So this should be positive 8 because it's negative 4 times negative 2. So two negatives give you a positive. So this would be positive 8. So now I have I want to isolate for y, and it's on the left-hand side, so I'm going to move the 6 over by subtracting it. So if I subtract 6 from both sides, I should get negative y equals to negative 4x, and now positive 8 minus 6, that should be 2, so negative 4x plus 2. Now since I have a negative y, not a y, I'm going to turn that into a positive y by dividing everything by negative 1. Okay, so negative y, which is pretty much a negative 1 in front for the coefficient, right? So negative 1 divided by negative 1, which is the negatives will cancel out, and then 1 divided by 1 would also just be 1. So I'm left with y. And then negative 4 divided by negative 1, x plus 2 divided by negative 1. Here, I would reduce as much as I can. In this case, negative 4 over negative 1 is just going to be 4. And it's 4 because 4 divided by 1 is 4. But then the negatives also cancel out between negative 4 and negative 1. So I'm left with 4x. And then for 2 over negative 1, that would become a negative, and that would give me negative 2. So my first equation is y equals to 4x minus 2. Now let's try to solve for our second equation. So for our second equation, we have 12x minus 3y minus 6 equal to 0. In this case, I want to get y by itself on the left-hand side. So I'm going to start by adding 6 to both sides, the left and the right. And if I do that, I should have 12x minus 3y equal to 6. Now I want to subtract minus 12x, or I want to subtract 12x from both sides. So if I subtract 12x from the left-hand side and subtract 12x from the right-hand side, what I should have left now on the left-hand side should just be negative 3y. And then on the right-hand side, I should have minus 12x plus 6. Now I just want y by itself, so I'm going to divide everything by negative 3 in order to cancel out negative 3y. So if I divide everything by negative 3, what I have left is y on the left-hand side, and then for the right-hand side, I have negative 12 over negative 3x plus 6 over negative 3. And I'm just going to show a little bit more steps for this one. So I have y equals to, so again, my negatives cancel out, so I should have 12 over 3x. And then I want to move the negative to the top. So I would have plus negative 6 over 3. now I try to reduce as much as I can. So 12 over 3, that's just going to be 4. So I have 4x. And then plus negative 6 over 3. So this would just be plus negative 6 over 3 should just be negative 2. So what I actually have is y equals to 4x minus 2. And that's my equation 2. But now notice something interesting here. Equation 1 is actually the same as equation 2. So when you graph this, you'll just get the same line on top of each other. Meaning for every value that you put in for equation 1, it would be the same as every value you put in for equation 2. This means that we have an infinite number of solutions. So since that's the case, we say there is an infinite number of solutions for this system of equations.